To find the sum of a geometric series. If I have a finite number of terms, like 5 terms, 6 terms, I'm going to use this first rule here. If I have an infinite geometric series, I'm going to use this second rule here. So if I take a look at number 3, I'm starting at the number 20, and I'm ending at the number 5 over 128. So this is a finite number of terms. I don't know how many numbers are in my list here. So to figure out how many numbers are in my list, I'm going to take this last number, 5 over 128, and plug it into my rule, a sub n is equal to a times r raised to the n minus 1, to figure out what my n is. So I'm going to take my 5 over 128 is equal to, I know 20 is the first term, and if I'm going from 20 to 10 to 5, I'm multiplying by 1/2. I'm going to get rid of this 20, so I'm going to multiply both sides by 1 over 20, and reduce that down, and I get 1 over 512 is equal to 1/2 raised to the n minus 1. I know that n is a whole number, so that's going to tell me that if I rewrite 1 over 512 as 1/2 to a power, then I can go ahead and compare my exponents. So 512 is 2 to the 9th, which means that I'm going to have 1/2 to the 9th is equal to 1/2 to the n minus 1. I can now set my exponents equal to each other, and if 9 is equal to n minus 1, then I get that my n is 10. Now that I know there are 10 numbers in my list, I can plug it into my sum formula. S sub 10 is going to be equal to the first number in my list, 20, times 1 minus r to the 10th over 1 minus r. So I'm going to take 1 minus 1/2 to the 10th, then I can divide that by 1/2 and multiply by 20, and I get 5,115 over 128. For my next one, this time it's written as sigma notation. So I know that the number underneath tells me which value to start with. So I'm going to start with the first term, and I want to add up the first 9 terms, and here's my rule. So if I look at my rule, a times r raised to the n minus 1, I know that the first number on my list is 2, and my common ratio is -3. So now I can go ahead and plug it into my sum formula here. S sub 9 is going to be equal to, take 2 times 1 minus r to the n, all over 1 minus r. Be careful with your negatives. Make sure that you use your order of operations, and when you take your 1 minus -3 to the 9th, all over 4 times 2, you're going to get 9,842. For our next two, for 5 and 6, these are both infinite geometric series. The only way to find a sum of an infinite geometric series is if it converges, which means that my r has to be in between 1 and -1. If my r is bigger than 1 or -1 for an infinite geometric series, one that goes on forever, ... then I cannot find a sum. It's just going to keep getting bigger and bigger and bigger. Looking at number 5, I go from 3 to 3/4 to 3/16. If I didn't know what my r is, then I can say that my first number 3 times r has to get to my second number 3/4. So if 3r is equal to 3/4, then if I multiply both sides by 1/3, I can see that my r is going to be 1/4. Now that I know my r is 1/4, the sum for an infinite geometric series is always equal to a over 1 minus r. So I'm going to take my first number 3 over 1 minus 1/4, which will give me 3 over 3/4, and 3 times 4/3 is 4. For number 6, if I'm going from 1/2 to -1 to 2 to -4 to 8 to -16, ... I'm multiplying by a -2. So for this infinite geometric series, it's not possible because my r is less than -1. My r has to be in between 1 and -1 for an infinite geometric series.